This is the lecture video for MAC 1140 pre-calculus. This is a continuation of section 10.3 on ellipses. And in this video, we're going to be covering numbers 10 through 14. Okay, so in problem number 10, we find an equation for the ellipse. They want us to find an equation for the ellipse and graph the equation. They start us off with this information, that the focus is at 15, 0, which means there's also a focus at negative 15, 0. So we're going to go, let's see, the scale that we could use here, since we have to go pretty far out on this x-axis, we could count. I'm going to use a scale of 3 on my x-axis. So this will be 3, 6, 9, 12, 15, 18. Okay, and then going back the other way, same thing. Negative 3, negative 6, negative 9, negative 12, negative 15. And then we can just approximate the locations that they are talking about, such as 17. Okay, so focus is at positive 15, 0, and the other one would then be at negative 15, 0. Okay, they're spaced equidistant from the center. So the center is going to be right here, and then the vertices are at 17, 0 and negative 17, 0. So that would be approximately right there, right before the 18. Okay, so that's one vertex and the other vertex. Okay, so from these values, you have to know what they are giving you, as you had to realize in the previous problems, that when they give you the coordinates of a focus, that is their way of giving you the distance c. From the center to a focus, going either way, that distance is designated as c. So c in this problem is 15. It's a distance, so we always think of it in a positive manner. When they give you a vertex, as they have from here to here, where you're at 17, 0, then they're giving you the a value. So the a value in this case is 17. And as you could see in the last 4 or 5 problems, they've been consistently giving you two of the three values in this formula. B squared is equal to a squared minus c squared, so that you could find the missing value in order to give the equation. So in this problem, what's missing is the b. Okay, so what you could do is you could go into this formula. I'm going to slide this down a little bit and do my work right above the formula. You could take this formula, plug in the two values as we have in the last 4 or 5 problems, and find the one that's missing. Okay, so it is b squared is equal to a squared minus c squared. Okay, 17 squared is 289, 15 squared is 225, and when you subtract these two, you get 64. So b squared is 64. Then when you go into finding b, you get b is equal to 8. Okay, so with regard to writing the equation, you now have everything that you need. You know that it's going to be, I'm not going to try and squeeze it into that box. Never works out for me. You know you're going to have this, an x squared and a y squared. They're both going to be positive. The one they've already provided for you. So you'd only be entering the left side of this equation in the box. And then notice that the foci, which are always on the major axis, are on the horizontal axis, the x-axis, and therefore that a value is going to be associated with the x expression, the expression containing x. So it's going to be x squared over a squared plus y squared over b squared, because you know that that's the only difference in the way this formula can be written. Sometimes the a squared is associated with the horizontal axis, sometimes it's associated with the vertical axis, but in this problem you can see what they've given you. So major axis is on the x-axis. Okay, so that a squared value was 289. 17 squared is 289. And the y, under the y squared, where we have b squared, well, b was 8, b squared was 64. Okay, so we had enough to write this equation. Okay, we also have enough to complete the graph. So when we complete the graph, we went a units to get to the main vertices, to get to the co-vertices on the minor axis, then we would be using the b value. This is the a value to the major vertices. Okay, so the b value was 8, so we would be going, I'm going to count in twos going this way. 2, 4, 6, 8. And this will be -2, -4, -6, -8. And I'll go ahead and plot those points, and then I'll connect my vertices. So I found this b value myself. It allowed me to construct my minor axis and also to complete the diagram. Okay, number 10. Moving to number 11. Number 11, we finally start to get to the ellipses where the center is no longer at the origin and instead it has been shifted, which you can tell by the fact that there are numbers either added or subtracted from the y values. You can see that they're in parentheses. Remember what the formula starts off as. Now in this particular problem, this has to be the a squared value. So where this came from is the formula, y minus k squared. And where this came from is x minus h squared. And then it just so happens that the larger number, the 81, is associated with the y expression, and therefore our major axis is going to be vertical, like a y-axis, because it's associated with the y expression. This, on the other hand, will be the value associated with our minor axis. So b squared is that 49, and I'll move out this way, and therefore b is equal to 7. Okay, so we know which one is our major axis. It will be vertical. It just won't actually be the y-axis because this the center of this ellipse has been shifted away from the origin, and so it can't be right on it's been shifted in your y coordinates as well as your x coordinates. Therefore the major axis can't be directly on the y-axis, but you'll see it as I graph it. Okay, so trying to graph as much as we can from the information that we have. Our center will be H and K. You must switch the signs when you're taking out values from anything that started off as an equation with minus signs in it. So you're basically asking yourself, what could be plugged in right there for H that would end up looking like this? And it would have to be +1. Not exactly what you're seeing there. Switch it. What could be plugged in right here that would end up being y plus 6? It would have to be -6. Again, opposite of what you're seeing there. So that is our center. So we've answered this question. And let's go ahead and plot that because everything evolves from the center. So we're going to go 1, and I'm going to go, let's see, I think we should be okay just counting in ones. So I'm going to go down to 1, -6, and I'm going to use ones on my y-axis. So -1, -2, -3, -4, -5, -6, and I'm going to go 1, 6. This will be 1. Okay, so there is my center. And then let's see. Actually, let me see if I'm going to be able to get away with this. If I still have to move from the center, I'm going to have to move 9 up and 9 down. So maybe it won't be such a good idea to count in 1. So let's change this. I'm going to change my scale for this particular graph just because I have to go pretty far away from the center. So in this problem, I think what I'll do is I'll let my y scale be 2. I'll count this as -2. Therefore, this will be -4, -6, -8, -10, -12, -14, -16, this will be -18, and so forth. We'll see if we have to go any further than that. Okay, so let's try and plot that again. I think on my y-axis, I'm also going to use, on my x-axis, I'm also going to use a scale of 2. I already did my y-axis. So 2, 4, 6, 8. Number a couple of them so you can tell what the scale is. And then 1 would be right here. And we're going down to -6. So it would be right in here, halfway to that first grid mark, and it would be down at a depth of -6. So this is my center. Okay, and then if I'm going to plot the rest of this and go ahead and get the graph, because I actually have enough to go and do that, I'm going to be going from my center in a vertical manner. Again, the bigger number, the bigger denominator associated with the y expression. Therefore, your major axis is going to go up and down. So you're going to move 9 spaces from here, which you can go and tell what the vertices are just from this, or you can practice the skill that I've been trying to teach you with respect to what coordinate changes when you're going up, and what coordinate changes when you're going down. I'll do it both ways. Okay, so if you're just doing it graphically, just visually, in order to get the vertices, you would be going 9 units up from the center. So you would just be going up 6, and let's number some of these so you can judge properly where to land. Okay, so you'd be going up 6, and then you need to go up another 3. That would put you right there. So that would be one of your vertices. And so you'd be at +1, and you'd be 3 units up in the air because this is 4. Okay, then if you were going to go 9 units down, then you would have to say -6, and then 9 added to that would be -15. And that would be your other vertice at 1, -15. If you want to do it algebraically instead of just counting out the grid marks with your finger, then it would be, okay, center is at 1, -6. You are moving up and down from that center. And it's helpful to know this skill, especially when the radicals get involved. So that means the y coordinate is changing. And when you're trying to go to a vertex, as we just did on the graph, well, that means you are moving a distance of a. From the center to any vertex, you're talking about a distance of a. So that would be the same thing as the y coordinate. What was our a value? It was 9. Okay, so if I went this y coordinate right here, -6 plus 9, you can see why I landed right at 3. The x coordinate does not change. Okay, if you were going down, you would subtract from your y coordinate. Again, subtracting that a value, which would just be -6, take away 9. You can put that in your calculator if you don't think you can do it in your head, but hopefully you can. Okay, and those would give you the 2 vertices. in a likewise manner, you could find the foci, which are also on the major axis. It's just that instead of moving up a distance of A and down a distance of A from the center, you're moving a distance of C. When you travel to the foci, one of the main themes in this section is that you're moving a distance of C. When you move to a vertex, you're moving a distance of A. Okay, so we just found the two vertices. Now I'll find the foci. And you don't have to do it in that particular order. You can find the foci first if you want, and then go and look for the vertices. Anyway, so let's start again from the center. Now let's see. Do we even know the C value? Because if we're going to get to the foci, we need to know the C distance. We need to know what that is. Yet all I see here on the paper so far is the A squared value and the B squared value, but then we've been working with pretty consistently how to get either A, B, or C from this formula. B squared is equal to A squared minus C squared. Okay, so let's see. That would be, my A squared value was 81. We don't know the C squared value yet, but want to know it so that we can move to the foci. And then B squared value was 49. So we'd be bringing this 81 over here, at which point it would be negative 81. And then we would have 49 minus 81. And that would be, negative 32 on the left side, while having a negative C squared on the right side. This 81 would be over on the left. Then we would divide off the negative 1, divide off the negative 1, leaving ourselves with 32 is equal to C squared, at which point we would want the C value rather than C squared. So we would finish that by taking the square root. Let me move that up here so you can watch me doing the partial square root. So we're taking partial square root of 32 because it's not a perfect square. I already took the square away. So we can break this down, try to break it down into the two factors, biggest factors you can think of, one of which needs to be something that there's a square root of. And that would be 16. 16 times 2 is 32. You can take the square root of this. In fact, that comes out as a 4. So that was a 16 underneath, but came out as a square root of being 4, and the 2 stays underneath it. So that's the partial square root. So it is this radical that you're going to need if you're going to try and find the foci. Again, it's from the center that you get to the foci. They're all lined up. The vertex, then the foci, then the center. So you're going to have to go up and down, thus affecting your y coordinate right from the center. Again, the center point was 1, negative 6. I'm just going to put C for center right here. If you're moving up, you're taking the y coordinate and changing it by however far you're moving up, and we are moving a distance of C. So it's going to be the y coordinate, and we're going to add that value of C, which is 4 square roots of 2. Now, since one of these numbers is an integer and the other one is a radical, you can't put them together any further than that because they want exact values, not decimal approximations, unless you're doing an application problem. So you have just moved from the center up a value of C in order to get to one of the foci. And if you're going to be moving down, then you take the y coordinate and subtract the C distance, which is going to be, again, negative 6, but this time we're subtracting the distance of C, and this was our distance of C. So minus 4 square roots of 2. So when you can't count it out with your fingers using grid marks on a XY system, it's good to actually know the actual skill of, hey, do I change the X or the Y? You change the Y when you're moving up and down. Up you add, down you subtract. And you change the x coordinate when you're moving left and right. Left you subtract, right you add. Okay, so this would be the other foci. So now we have the center, which was suggested right by the numbers that were in the equation. Denominators gave us a squared and b squared. This formula right here allowed us to find the c value, and then finding that c value right here allowed us to get to the foci finally. Let's complete the graph though, because we haven't graphed the whole graph. Okay, so what's needed further to complete that ellipse is that, let's see, we have the vertices, we haven't graphed the co-vertices yet. So from the center, we're going to move that value of b. The b value was 7, and I'm counting in twos here, so this would be 2, 4, 6, 7. And this, then going back the other way, you're also going to move 7. And hold on, let me make sure that, I don't think I have that right. I was at 1 and I wanted to move 7, so actually I would be at 8 because I'm starting at 1. Okay, that's 1, and you're adding 7 to that, so you would actually end up right there at 8, and you're down at a depth of -6. And if you're going to move 7 spaces this way, well, you're already at 1, so if you move a total of 7 spaces, that would be 1, and then you'd have to move 6 more. So it would be -2, -4, -6, -8. Okay, 7 spaces. Once again, you're moving 1 to get to the y-axis, and then you'd have to move 6 more spaces. 2, 4, 6. And that would put you at your other co-vertex, -6, -6. Just in case they ask you to name these things. Then connecting all of your vertices, your 2 vertices, and then your 2 co-vertices will give you the exact width and shape of the ellipse. Okay. So there's the ellipse and all of the questions answered. We did the center, the vertices, the foci, and we also graphed it. Okay, moving to number 12. In problem number 12, this time you see that there aren't, it's not in elliptical form for graphing. It's not ready for graphing yet. And in fact, because you don't see any parentheses or anything like that, you're going to be left to do what's called completing the square. And when you're completing the square, there are several steps. You have to look at the problem and see whether you have a second degree and a first degree term for a particular family. For the X family, we do have both of those terms, therefore we can complete the square. For the Y family, we also have a squared term and a linear term, first degree term, and so you can complete the square for that family. So I'm going to review with you the steps for completing the square. Now I'm going to need quite a bit room just to do that as well as all the other steps, so I'm going to start up here. Okay, now you already have your family members together. You have the 2 X family members together and the 2 Y family members together. So when you complete the square on a family, you have those 2 family members together, leave room to create what's called a perfect square trinomial on your X family. That's the completing the square portion. And you start that off by cutting that linear coefficient in half, which is -2, and then squaring it. And you get 4. Now let's copy the rest of the terms into this problem as well. And I just want to say on this Y family, notice that the squared term has a coefficient that's bigger than 1. You have to factor that out before you complete the square on that particular family. So this would actually be take out whatever the coefficient is before you set up this parenthesis. So let's get that ready first. So it would be 9 times y squared, and then I believe we had an 18y, but the 9's already out there, so that's going to be 2y. Leave room to complete the square on that y family, and then you're going to put all your constants over on the other side of the equal sign. Let me give myself a little bit more room here. And we'll just keep a running tally of the constants. Now, one of the constants was 4. You need to get that 4 on the opposite side. So I factored out the 9 to get myself ready to complete the square on the y family, and I moved the constant to the other side. So I have one constant on the right-hand side, which is a -4. Okay, let's continue. So this first family was easy to complete the square on because the leading coefficient was just a 1, and then therefore you can jump into the first couple of steps for completing the square on any particular family, which is to cut the coefficient of the first degree term in half and then square it. You're getting a 4 here, so that completes this family. You have just created a perfect square trinomial. Now, because you've added 4 to the left side of this equation, you must add 4 to the right side of the equation, because an equation is a balanced statement. It's balanced on the left and the right side. So if you're going to add 4 to one side, you must add 4 to the other side. Okay, now let's complete the square on this family. You've already taken the 9 out because you can't complete the square unless the coefficient on the squared term is 1, and that's why if it isn't, you need to factor out that leading coefficient on that particular family. Okay, so as I try to complete the square here, let me just write my steps right here. I'm going to do my work on this line, and then on the next line we will write it in factored form. Okay, so just like I did right here for the x family, I'm going to cut that linear coefficient in half, which is 1, and then I'm going to square it, just like I did here. Cut it in half, then whatever you get, you square it, which is what I've done here. That gives me a 1 as my third term, thus creating a perfect square trinomial again on my y family. And because it looks like you've added 1 there because that's the number you created, but in actuality, any number that is in this parenthesis is impacted by the 9 that's out front. So when you go to decide what you're going to add on the right-hand side to keep the left and the right side balanced, you have to say, okay, yes, I did put a 1 there, but in actuality, that's really a 9. 1 times 9 is 9. So you have to come here, and because you've created a 9 on the left side of this equation that wasn't there before, you must compensate by adding 9 on the right side of this equation. I'm in that room here. There. Okay, so after you've done the first 2 steps of completing the square, I've done it for the x family, I've done it for the y family, and made some comments about factoring out that leading coefficient because it wasn't a 1. As soon as you create these perfect square trinomials where needed, you are then going to factor your perfect square trinomial. All perfect square trinomials factor very easily. They all end up looking like this once they get factored, and all you do is you take the square root of this first term and the square root of the constant. You're going to take the square root on both of these terms. Square root of x squared is x, and when you go to take the square root here, it's 2. You will join these 2 terms by the sign in front of the linear term. So this perfect square trinomial is the same thing as x minus 2 times x minus 2. If you FOILed it out, you'd be right back to this. We want to put it in factored form because we're trying to get this equation in the form that all your elliptical equations have been presented in. Okay, then for this other perfect square trinomial I created on the y family, there was a 9 out front. I want to factor this perfect square trinomial, so I take the square root of the front, square root of the constant, join these two terms by the sign in front of the linear term, and put that square on it. Again, all perfect square trinomials factor like this. Okay, add up all the numbers that you have on the right side. So the 4's cancel because one's negative and one's positive, and you're left with just a 9. Then let's go back to thinking about what have all the equations looked like that you have graphed in this particular section. All of them had a 1 on the right-hand side. So when you're not given, when you don't have an equation in that form, then you're going to create the 1 by just dividing whatever this number is by itself. That'll create the 1, but whatever you do on the right, you must do to every single term on the left. So you'd have to divide this side by 9 and this by 9. That gives you x minus 2 squared over 9. And then on your y expression, these 9's would cancel. 9 divided by 9 is 1. That would be the denominator of your y expression. And then that would be equal to, let me just lower this, make it look a little neater. And this would just be equal to 1. Okay, so now we have an equation which we did quite a bit of work for, and we used the procedure called completing the square, which is used quite often when you're dealing with conic sections, because it is how you find the center of the conic section and how you're able to find key values that will help you actually graph the conic section. So we now have our equation in a form that will allow us to tell what the center is. Now you're going to take out the center. Remember, the center when it's shifted is just the h and the k value, and in this particular case, that would be positive 2, negative 1. And I explained, in previous problems, the significance of looking at this compared to the formula from which it came, which is x minus h squared. So the positive 2 would have to be what was plugged into that particular formula. And in the formula, this is first presented as y minus k squared. So this would have to be your k value. Okay, so I know my center. And then I'm going to go on to do these other things. So I'm going to plot that point. Let's see, for this particular problem, let's see, how far do we have to go? I think we can probably get away with using a scale of 1 because these numbers are not very big. So I'm going to stick with each grid mark counting for 1. So this will be 2 right here. Actually, I can't even put that there because it'll be in the way. Everything's always in the way. So go to 2 and then go down to negative 1. That's your center. Okay, then moving from the center, I have to recognize values that are also suggested by this equation. This would have to be the a squared value because it's the larger of the two denominators. Therefore, a is 3. So the major axis is horizontally positioned. Okay, notice that this a squared value and a value is associated with the x expression. So therefore the major axis is parallel to the x-axis. And then this would have to be your b squared value. Therefore b is equal to 1. So the minor axis is parallel to the y-axis. So if we are going to have our major axis being horizontal, that means we have to stretch out this way and stretch out this way to get to either the foci or the vertices. Right now I have enough information to get to the vertices because I have the a value. So from the position that I'm at right now, which is 2, -1, I want to take that 2, -1, and I want to move over A units. So I'm going to take the X value and add the A value to it, which in this case would be 2, and then my A value is 3. So I'm moving over to 5. I'm only changing my X coordinate because all I'm doing is moving to the right, which means your X coordinate changed. Okay, then I'm going to move to the left, which means I'm going to take my X coordinate and subtract the A value because I'm trying to go to the vertices. This is one vertex, this is the other, in case I did not explain that. That's why I'm adding the A value, because I'm going to the vertices. So, the X value, which is 2, and then subtract the A value. And so now we have both of the vertices. One at 5, -1, and the other one at -1, -1. Okay, if you want to get also, and you can even plot those now. If you want to go to 5, this is 1, 2, 3, 4, 5. And you'd be moving down to -1, lining up with the center. And if you were at -1, -1, you'd be right there. So that's a vertex. This is a vertex. If you want to go to the foci, then you need C. The foci is associated with C, just as you've seen in several of the problems. So I'd have to use this formula. B squared is equal to A squared minus C squared. Okay, our B squared value is 1. Our A squared value is 9. And then it's minus C squared. If I subtract 9 from both sides, I would have -8 is equal to -C squared. And then if I divide by -1, divide by -1, I would have 8 is equal to C squared, at which point I'd get rid of the square and take a partial square root. 8 is the same thing as 4 times 2. You can take the square root of this, which comes out as a 2, with this 2 staying inside the radical. And that is your C value. That C value is what you're going to use in order to get to the foci. Okay, so foci is also measured from the center. So again, we are moving, if we're moving this way to get to a vertex, we're also moving this way to get to a foci because they're all lined up. So it would be the center. The center is at 2, -1. Okay, and then if we're going to move this way to the right or to the left, you're impacting the X coordinate. But this time we're adding C because we're trying to get to a foci, to a focus. So focus on the right and the focus on the left, plural foci. So one focus is, okay, take your X coordinate, add the C value. That C value was 2 square roots of 2. Leave the Y coordinate alone. Okay, and if you're going to go this way, then you're going the X value minus C. Whenever you're moving to the left, move to the right, you add, move to the left, you subtract. Okay, so then again, you're taking the X coordinate, but this time you're subtracting the C value while leaving the Y coordinate alone. And so we found the focus on the left, And the focus on the right. Okay, then, okay, let's see. So what's left? We also have to graph this equation as we have in all the other problems. So we need to have the major vertices on the major axis, and you can put these right into the picture. I mean, if they ask you for exact coordinates, there'll be a way in MyMathLab to actually type these in. But if you just want to get an approximation of where to place them, they always come before the vertex. They're all lined up with the center and the vertices, and you can always put that in your calculator to just kind of get a decimal approximation of where this lands. It would just be 2 plus 2 squared roots of 2. Okay, so about 4.8. So this would be 1, 2, 3, 4, 5. So right about there would be the foci. And then you could just come out and label it. And then the other foci would be right about there. It would be as close to that vertex as this one is. And again, you could get a decimal approximation. Moving on to get the co vertices, so you can actually connect and get the actual graph, you'd have to move a value of b up and a value of b down. So if the b value is 1, and you're down here at -1, you have to move this again. Once you write something, you need to get it out of the way. It's hard to label anything on the graph. Okay, so you're down here at -1 for the center. So if you're trying to move the b value so that you can figure out how wide it is this way and this way, you're moving 1 unit up and 1 unit down from the center. Then connect the vertices with the co vertices to get the graph. Okay, so there's your ellipse. So we've done the center, we've done the foci, we've done the vertices, and we have graphed it. Okay, moving on to the last one where we're graphing. I think the 14th problem is an application problem. Find an equation for the ellipse. Graph the equation. Okay, so all we need to do is, all right, let's do this. So remember, the foci is associated with the C value. So they're always kind of starting you off in a slightly different way. Sometimes they're giving you B and C. Sometimes they're giving you A and C. Sometimes they're giving you B and C. So they can start you off with different values, and in each case you're just trying to realize that you're using that other formula, B squared is equal to A squared minus C squared, to find whatever you're missing if required to answer the question. So it says that the foci are at, let's see, 5, -1, 1, 2, 3, 4, 5, 5, -1. Let's keep our head on straight that that's a foci. And then the other foci is at -3, -1, -1, -2, -3. Down here at -1, and this is my other foci. So by knowing where the two foci is, you can find the center, because the center is always midway between the foci. It's also midway between the vertices. So let's find out where the center is, because as soon as we find out where the center is, then we can figure out what the distance C is, the value of C. Okay, so let's see. This is a total of 8 spaces. So if you just cut that in half, you get 4. So 4 from either end. You can move 4 this way, or you can move 4 from this side. Doesn't matter. You're going to end up at the same point in the middle. Okay, so we're going to go line up with these two and go 1, 2, 3, 4. Right there is the center. Okay, so this distance right here, or this distance right here, from the center to either foci is called the C value. I'm trying to make this look like a big C for center. So that's my C value right there. And then let's see, what else do I know? I am also given this information that the length of the major axis is 18. Well, the length of the major axis means from one vertex to the other. Now, when you're at the center is in the middle of either of the vertices. So you're going A this way and A this way. Or you could call this a total of 2A. So 2A is equal to the 18 that they're giving you, and therefore they have also given you the A value. Divide by 2, and you would get 9. So we know the A value, and we also know the C value. So once again, you have 2 of the 3 values, and if you're going to write the equation of the ellipse, you also need the B value, and thus you must drag in this formula here. B squared is equal to A squared minus C squared. We don't know B yet, B squared, but we do know A. We're going to square it. We do know C. We're going to square that. 81 minus 16 is 65. So if we're going to get just B, we take the square root here. I don't know why I'm putting a square there. Okay, so B squared came from 81 minus 16, which was 65. We take the square root here to get rid of the square, and we take the square root there. So B is equal to square root of 65. Now, even if you did break this down, they're both prime numbers. That means you're not going to be able to take a partial square root, so you just have to leave it as 65. So just B is equal to square root of 65. As far as writing the equation, we have everything we need right now in order to write that equation. It's going to be x squared over a value, y squared over a value, and that's equal to 1. Let's get our head on straight about where the a squared goes. Notice that everything as far as the foci and the vertices, when you go out to the vertex, which is going to be used for when we graph it, we haven't gotten there yet, but when we go out to the vertices, we're going to go from the center, and instead of going 4 units to get to the foci, we're going to go beyond that. Let me get these numbers out of the way, because as soon as you label something, it's in the way. So I don't know why I keep doing it. Okay, so you're going to go beyond that, and you're going to go a distance of 9. We only went a distance of 4 to get from center to focus, and then we'd be going a distance of 9. So if we're at 1 right now, and then we add 9, we'd be at 10. So this would be 5, 6, 7, 8, 9, 10. Now, they don't specifically ask you for the vertex, but of course you could get it. As I said, you were at 5 after you moved 4, and then if you moved 9 from this center, you would be at 10. You'd be at 10 down at a distance of -1. And if you did the same thing, moving 9 units to the left from the center, you would be, this is 4, 5, 6, 7, 8, 9. So you'd be right there. And that, again, they didn't ask you for these, but I'm just going to label them anyway. You should be in the practice of naming them, because in plenty of the problems they ask you for those. So this was 4 units, 5, 6, 7, 8, 9, and that is 4, 5, 6, 7, it's at -8, because you started off at 1. So we moved a total of 9 spaces from +1 that got us to -8, and all of these points are down at a level of -1. Anyway, so we have the vertices. Everything is horizontally orientated, the A value and the C value. So This depicts the major axis right here that connects the two vertices and goes right through the center. So that a squared value is going to go under the x expression. So a was 9, this is a squared. And then this is b, but if you square this, there's the b squared right there, is just 65. The 65 goes here. And you're only feeding in this part each time you do these problems because they're giving you the equal sign and the 1. And then if you were going to finish this graph, you'd have to go plot the co vertices. So again, this was square root of 65. So if you wanted to plot that, it would be, let's talk about that. The center is at, let's see, the center is at positive 1, negative 1, positive 1, negative 1. And if I want to do the co-vertices, I'm going up and down by a measure of whatever the b value is. Okay, from here to here is a distance called a, and that distance was 9. But when you go to the co-vertices, you're going a distance of b. Okay, so since I'm going to be going up and down from the center, which is 1, negative 1, I'm going to be impacting the y coordinate. Okay, so it is the y coordinate, add that b value. Okay, so the actual coordinates for the co-vertex would be, leave the x alone, you're moving up, and therefore you're only changing the y coordinate. Okay, so it would be negative 1 plus square root of 65. And you can get a decimal approximation of that if you want to see where to hit it on the graph. And then if you were going down from the center, so this is a co-vertex, then you would have the y value minus square root of 65. So this would be 1, and then the y value minus square root of 65, and you would be at the other co-vertex. Okay, if you want to know what that is as a decimal, it would just be negative 1 for the top one plus square root of 65. So you're up at approximately just a little tiny bit higher than 7 when you go up. Be 1, 2, 3, 4, 5, 6, 7. Okay, so let's see. So you'd be at 1, and like I said, this is approximately 7. You'd be over at 1, up 7. Tiny bit higher than that because it's 7.06. Okay, so this would be one co-vertex giving you the top of the ellipse, and then if you want the bottom of it, you have to go down from the center point. So that would be this right here, the other co-vertice, negative 1 minus square root of 65. Let's see what that's approximately equal to. That would be negative 1 minus square root of 65. And that would be approximately a little bit lower than negative 9. So this would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. It's a little bit lower than that. And if they ask you to label these co-vertices, well, you have them. This one's called 1, negative 1 plus square root of 65. And this one down here is called 1 and then negative 1 minus square root of 65. Okay, that's if they ask you to label the co-vertices. So that's everything. Okay, working backwards from the problem, the values that they give you. Okay, last problem in this section is an application problem. And it says that there is a hall that's 140 feet in length, and they're going to use it to design a whispering gallery. If the foci are located 30 feet from the center, how high will the ceiling be at the center? Give an integer of decimal answer. That probably meant that I copied this right from my math lab. That sounds like a typo. An integer or decimal answer rounded to one decimal place. Okay, so let's try and draw some of this out. We are going into a hallway that is 140 feet long. Okay, we're going to place some foci, which are located 30 feet from the center. So let's make this the center, and then the foci, there'll be one here, and it is 30 feet from the center, and then there'll be one going back the other way, as is always the case. And this will be 30 feet. Okay, then let's see. The other thing that they're asking you is, now if we were going to find the A value goes like this. It goes from the center all the way out to here. That would be the A value if we were going to find the edge of each side of the hallway. That would be the A value. But if you're going to go up in the opposite direction, if you're going to go in the perpendicular direction as opposed to where all the foci in the center is located and the two vertices, then that's the B value. So you want to know how high up from the center should the ceiling be. And so you're really just looking for this B value right here. Okay, so let's see. What do we have here? We have that from the center to the foci, that's 30, so we know the C value, because the C value is always the distance from the center to the foci. So that's 30. We also know the A value. From the center out to the end of the hallway, being that this is 140 feet long, that would be 70. So we also know the A value, and that's 70 feet. So if we're trying to find the B value, so we know how high up from the center the ceiling should be placed, that means we're just once again missing one of the three values. So using the formula that we've continued to use whenever we were missing one of the three values, it goes B squared is equal to A squared minus C squared. A squared value in this case is 70 squared. The C squared value would be 30 squared. We're looking for B squared. So 70 squared would be 4,900. 30 squared would be 900. 4,900 take away 900 would be 4,000. And that's what your B squared value is, but you want B. So you're going to take square root of this side, square root of this side, and B is approximately 63.2 feet if you feed that into your calculator. Okay, that concludes section 10.3 on ellipses.